Pythagoras is a really useful equation, and it is certain to come up in your exam. Let's just think about right-angled triangles for a moment. We know it's a right-angled triangle because it says so, and also because of this box down here which says that this is a 90-degree angle, a right angle. So if the question's only about lengths, then it's going to be Pythagoras. And we can label this A, B and H. H is the hypotenuse, and A and B are the other sides. And we know that A squared plus B squared equals H squared. It also means that given two lengths, we can find the third length. Now, conversely, lengths and angles, if we start to see angles appearing, then it's not Pythagoras. We start labelling this up as opposite and adjacent relative to this corner, and we're using sine, cos or tan, or my old favourite, SOHCAHTOA. So when it's lengths only, it's Pythagoras. So, the Pythagoras theorem, a squared plus b squared equals h squared. It's sensible enough, and it means that given two lengths, we can find the third. So, if we take a squared plus b squared equals h squared and we subtract a squared from both sides, we see that b squared equals h squared minus a squared. Similarly, if we subtract b squared, we get that a squared equals h squared minus b squared. You can see there's symmetry in these two equations. H squared, of course, is the largest of all these values. And that's why h squared is always the largest. The largest less 1 equals the other. That's the way I remember it. The largest less 1 equals the other. And the largest less 1 equals the other. But it sort of becomes intuitive the more you use Pythagoras. Essentially, find two side lengths and you can find the third. Here's an example. Here's a right-angled triangle. We know that because it's in the question and it's got this little box. Work out the value of x. Well, obviously this is a Pythagoras question. Here's my old mate and here's his theory. A squared plus b squared equals h squared. We immediately label it A, B, H. H, A, B. We can barely go wrong now. A squared plus b squared equals h squared. We've got a and b lengths, so that's 5 squared plus 12 squared. 25 plus 144 equals 169. So x squared equals 169. We'll take the square root, and that's 13. So x equals 13. We can check this. 5 squared plus 12 squared equals 169. 13 squared equals 169. I can feel very good about that. So that's a very simple application of Pythagoras to find the length of an hypotenuse. The trick we had, what did we do? We had a little think, we did a calculation, and we checked it. This is the tricky one. Here, we're not looking for the hypotenuse, which is this line, we're looking for this. So the first thing we do, well, it is Pythagoras, there's no angles here, it's just lengths. A squared plus b squared equals h squared. Right, mark A, B, H. So H, oops. Here we have the question the hard way round. We have the hypotenuse. They're wanting us to find one of the sides. So again, think, no angles involved. It's Pythagoras. A squared plus b squared equals h squared. So the first thing we do is mark A, B, H. A, B and H for the hypotenuse. Once we've done that, things should go quite well. A squared plus b squared equals h squared. X squared plus 4 squared equals 5 squared. Right, there's x squared there. So x squared plus 16 equals 25. I'll subtract 16. X squared equals 9. X equals 3. And I'll check it. Let's put 3 in here. And our sides are 3 squared plus 4 squared equals 25. Which is, of course, true. And 5 squared equals 25. I'm feeling good about that. So have a think. Are there any angles involved? No, in which case it's Pythagoras. So let's mark it up, A, B, H. Do the calculation, shouldn't be too complicated, and then finally check it. These questions are very easy to check. So what goes wrong? Classic fail here. Classic way to misuse Pythagoras. Here's a right angled triangle. We're trying to find this length here. Work out the value of x. We don't bother to label it ABH. No, because we're far too good at this. So we know it's Pythagoras. Here's our Pythagoras. AB and B squared equals h squared. So I just take these two and square them. 15 plus 12 squared. And that equals some enormous number. And then I get x equals 19.2. Well, that makes it the longest side. What we've done is we've forgotten that A and B, this isn't A and B, this is, say, A, and this is H. What we should have done is squared 15 and subtracted 12 squared. Mark ABH. And if you do that, you are much less likely to make this mistake. It's not really a mistake, the other sort of failing with these questions is not recognizing Pythagoras. And this is a deliberate thing because sometimes examiners make the questions harder, and I call them hidden Pythagoras. Here's an example. Here is an isosceles triangle with height 5 cm, base 24 cm. Find the perimeter of the triangle. Well, we know this length, but we don't know this length. Now, interestingly, isosceles triangle tells us that that and that are the same. These two sides are the same length, which means that this peak is in the middle of the base. It's symmetrical. It's another thing they can say. One line of symmetry. So this point here is 12 from here, 12 cm from here. So we can draw another right angle triangle. Well, it's right angles because of this square, but also because this is a vertical height. 12 cm, the base, because it's half of this. Height is still 5 cm. And now we're trying to find this. So let's 5 squared plus 12 squared equals h squared. H equals 13, you will discover. So the perimeter is, of course, h plus 24. H plus 24 equals 50 cm. This is it can be tricky if you don't spot them, but hopefully that's going to make it easier. Why not subscribe if you've enjoyed this video, or indeed if you haven't. There's plenty more coming. See you soon. Best of luck.